Hello guys, welcome you all for this end-to-end session of AIML where you guys gonna learn everything that you guys need in order to become a successful data scientist. Hope you guys are enjoying. We are enjoying a lot and we are learning a lot each and every day. Hope the same thing for you guys. And yeah, before coming to this session, as always, please make sure you guys watch all the previous session videos so that you guys are able to have better understanding of what we are talking. Today is a continuation of previous session where we have introduced you to the new concept called as LSTM in order to handle the sequential data. We have introduced you what is LSTM, what are the gates available in LSTM, how the LSTM works in the previous session. Please make sure at least you guys watch a previous session video so that you guys can understand this one. Okay, so and one more thing, we are having nearly 3000 plus quizzes in our YouTube channel. Please make sure you guys go and attend it. It can be right or wrong, guys. First thing, just go and attend it. Okay, that's the thing. So yeah, without wasting any time, let us jump into today's session. And one more thing, please make sure you guys subscribe to our channel so that you doesn't miss any of our videos. Subscribe and press the notification icon so you'll be get notified whenever we just upload a new video. Okay, so let us dive into today's session. Today's session is a continuation of LSTM session which we have done in the previous session. Let's see what we are having today. We are having the application of LSTM in data science. First is time series forecasting. Yeah, it is a sequential data, right? Then it's gonna have the LSTM. LSTM's ability to capture a long-term dependency makes it highly effective for the forecasting tasks such as stock price prediction and demand forecasting. Yeah, because the stock price prediction and forecasting, like demand forecasting, gonna have a time series data, right? Then we can apply this LSTM. Natural language processing, yeah, NSTM is widely used in NLP tasks, including model like language model, text generation, and machine translation due to its understanding of sequential data. For example, guys, consider I'm having a statement like I am going to temple. I is the first thing. What is the next thing to come? Am. When I give I to the model, it need to predict am. This kind of sequence in the data can be managed and handled by using a sequential model which is called as a LSTM, one of the model. Then speech recognition, it is also sequential, right? LLM, like LSTM based model excel at processing and recognizing speech by accurately modeling the temporal and contextual aspects of the audio data. You guys, actually during my MTech, I have built a speech to text model from scratch where I have used this LSTM as a layer for creating the sequential data. Okay, that much capability this LSTM has, because whenever the data is in a sequential manner, you guys just blindly go for this LSTM, it will work. Okay, anomaly detection, yeah, LSTM's ability to learn patterns in the sequential data makes it useful for detecting the anomaly in time series data such as network like some kind of issues and then or equipment failures. Okay, yeah, anomaly is like whenever we are having a proper sequence, that is a sudden spike, then that is an anomaly, right? We can able to find by using this LSTM. Okay, either it can be a time series forecasting or natural language processing or speech recognition or anomaly recognition. Everyone has something inside called as sequential data handling. So whenever there is a sequence of data, we need to handle it in a manner like a memory. So whenever we need a memory, we need to go for RNN. Whenever there is an RNN, we need to go for LSTM, which is used to contextually able to like grab and remember and able to have a long-term memory of large volume of data. So these four are the application of LSTM. I will not say this is one, these are four only the application of LSTM. There are n number of application for LSTM. As always, the slides can accommodate only four, so I have just put four. Okay, hope you guys are able to understand. So yeah, so over to you.
Yes. So, guys, application of LSTM in data science. So, time series forecasting, that is one thing. Natural language NLP is another. Speech recognition, anomaly detection. And you can apply this anywhere, wherever you have a scope in the industry, n number of industries. If you have problem statements connecting to these four things, you can go and apply. LSTM's ability to capture long-term dependency makes it highly effective forecasting tasks such as stock price prediction, demand for. So this is what forecasting. Wherever you need forecasting to make decisions, it can be any industry, guys. It's not only stock. It can be financial. It can be so forecasting is for decision making, so that whatever decision you are making now is relevant for the future. Okay, so that you are always optimizing your objective function. So NLP, you can use it widely. LSTMs in NLP applications like modeling text generation, machine learning translation due to okay, so due to its understanding of sequential data. So this is going to help okay, understanding all the aspects. It is going to learn properly for the sequential data for NLP. Speech recognition, again, this excels the processing of recognizing speech by accurately modeling the temporal and contextual aspects of audio data. What is temporal and contextual? Temporal is what is the temper of that particular speech? What is the context? Because we human beings really don't communicate based on straightforward communication, right? We always communicate on a contextual format. If something has somebody said and he will say something, it will have a very humanistic understanding about that particular thing. So that we have that aspect is in LSTM, guys. That is a very good aspect of temporal and contextual. Like in even in Chat GPT, you have to give context to generate a specific kind of um, content, right? You without giving context, it will give you vague answer, or you will that won't be specific. Okay, so anomaly detection, again, LSTM's ability to learn patterns in the sequential data makes it useful for detecting anomalies in the time series data, such as network intrusions or equipment failure. So it will predict, because it will know, okay, this is the past behavior, this is how it has happened, and there's a possibility that again the anomaly might happen because of these patterns in the sequential data. This is how it is very powerful tool. It can be applied to n number of industries where you have scope of these four things you can implement. Let's move to the other section.
Yeah, sir. Let's move on to the next one. Okay. Yeah. Benefits of LSTM over the traditional models. I hope like already you guys know. Let's put it in the words. Long-term memory. LSTM gating mechanism allows it to selectively remember and forget information, enabling the capturing of long-term dependency in the data. Because LSTM has something which is unique called as forget gate, which will forget the unnecessary information. So it is able to have a context which is very, very important. That's it. Improved performance. LSTM's ability to learn a complex pattern in sequential data leads to a significant performance and improvements in various data science tasks. Yeah, since it is able to have a context which is very, very necessary for the next state, it improves the performance of the data science process. Flexibility. LSTM can be easily adapted and integrated into a wide range of data science applications from forecasting to NLP tasks. You guys have already seen. It can be applied to a numerical data as well as it can be applied to a text data. I hope like this is the only model which can accept both the things. It needs only one thing, sequence. That's it. If it is there, then it's gonna get it. Okay. Next, robustness. LSTM models are more resilient to noise and missing data in the input, making them suitable for real time or real world data science problem. Yeah, this LSTM, we can have a data and a null values, we can have data zeros, we can have a missing values, but this LSTM works fine because it is able to get only the important information and remove the unnecessary information by using gate called as specifically called as forget gate. Okay, so these are the benefits of LSTM over traditional models like long-term memory, improved performance, flexibility and robustness. Okay, hope you guys are able to understand. Yes sir, over to you.
Yes, so benefits of LSTM over traditional models, let's understand that. So long-term memory, LSTM's gating mechanism allows it to selectively remember and forget the information, enabling capturing the long-term dependencies in data. We know that it is going to work as long-term memory, which is a human aspect, okay? The inspiration is from there. So long-term will always have the essential information with it. It captures that. So in the long-term dependency in data, that's it. Improved performance, LSTM's ability to learn complex patterns, sequential data leads to significant performance improved in various data science tasks. Then there is a flexibility, it adapts, integrates into wide range of data science applications, okay, from forecasting, neural networks, and other. So it has flexibility, robustness. Again, it is more resilient to noise, okay. It has resiliency, okay, and missing data in the input makes them suitable for real world data science problem. That is why you can see, guys, these days these models are close to, I'll say close to human intelligence, which is general AGI, which is human like general intelligence. We are moving towards that. We are in a period of weak AI towards general AI. I'll say we also call it human level intelligence. We are going towards general, and then we'll go to a super AI in coming years. So keep learning deeply all these concepts, and let's absorb the information, digest the information, and apply the information. With this architect and the human architect, this is the learning architect. Then we have the architect with persistency, consistency, perseverance, and patience, and long-term objective function, objective of career and whatever objectives you have. And with this architect, with these two architects, let's build our world's number one and best, become world's number one and best data scientists, AI researchers, or deep learning or AI ML researchers. Keep learning deeply. Let's move to the other section.
Yeah, sure, sir. Let's move on. Okay. Yeah. Challenges and limitations of LSTM, guys. There is two sides of coin, right? Similarly, what are we have seen about the benefits of using LSTM. Let us see what are the challenges that we have. Overfitting. LSTM model can be proven to overfit, especially when the training data is smaller. Requires a careful regularization, hyperparameter tuning. Yes, true, right? It gonna it gonna learn from each and every pattern. That's the reason it leads to overfitting when we are having very minimal data. Computationally complex, because the complexity of LSTM internal structure can lead to increased computation requirements, making it challenging to deploy or resource on resource constrained devices. Because like this LSTM has three gates, like it has a forget gate, input gate, and output gate. All gates has to need to process in a sequential and parallel manner. Parallel manner. That's the reason what happens means it's going to consume more resource. So it's computationally very heavy and challenging. Okay. Then interruptibility. The inner working of LSTM model can be difficult to interrupt, which can be the drawback in the application where model transparency is very important. Yeah, I can say the three gates that we are having, right? What a forget gate do? It will forget the unnecessary information. Input gate, it is used to add a new information to the uh, cell state. Output gate, which is used to determine what data has to be outputted from the current state to the next state. We know that's it. We know this only. We don't know what the black box behind it. Like we know the black box, but like we doesn't know the very in-depth understanding. That is a there is no transparency. Everything occurs by using a max. So there is a less, or it is challenging to understand the internal working. Or we will put it in a simple manner. It is not transparent. We know the internal working, but it is not transparent. It is completely hidden. So that is what one of the one more like challenge. Overfitting, computationally like complex and expensive. Interpretability, so less interpretability. So these are some of the challenges and limitations. So yeah, sir, over to you.
Yeah, so challenges and limitations. Overfitting, LSTM models can be prone to overfitting. So you guys know the term keyword or fitting. Okay, so what it is, can you just write in the chat box so what it is overfitting, especially when the training data set is small and requiring careful regularization and hyperparameter tuning. So that is this, and then there is a computational complexity. Um Complexity of LSTM internal structure leads to increased computational requirement, making it challenging to deploy on resource constrained devices. So I'll say that you will not actually, what Raja already has explained, that you will not actually, like, if you suppose, I'll tell you, if you want to know what is the problem in computer, you can open the computer and see whether it is a hardware problem or software, right? You can see that, but in this you can't see that because it's very complex. You can't see the internals of it. Okay, then interdependent inner workings, like which is already explained. The challenge, that like one is the deployment of when you're deploying, and there is a challenge because of resource constraints. That is the computational complexity. But interpretability is that the what I have explained, that you cannot see the internal workings of it. Okay, and that is a challenge. Yeah. Let's move to the other section.
Yeah, sure, sir. Let's move on. Okay, let's see what we are having last. Okay, let us see what are the conclusion future decisions we are having or directions. LSTM has revolutionized the field of data science, enabling the effective processing and analysis of sequential data. As a research and development continued, we can expect to see further enhancements or advancements in LSTM based model leading to even more powerful and versatile application in the years to come. I will say this was also not a feature, it is a present. We have built something called a chat GPT where the base comes from LSTM, which is transformed to transformer, and then we are having a transformer architecture which leads to chat GPT. Okay, guys, yeah, this is what the thing. Putting in a simple manner, LSTM is a kind of a model which is used to handle the sequential data. It can be text, it can be numbers, and it is used to keep a memory of long term, since it is having a different gates. Like forget gate will forget what are the unnecessary information. Input gate used to add a new information to the cell state. Output gate will fix what the output has to be to the next state. Okay, so this is what the entire thing about LSTM, guys. Hope you guys have understand and enjoyed. So this is all, I will say it is a black box of LSTM. Okay, hope you guys are able to understand. And yes, sir, over to you.
Yeah, guys, there are a lot of like revolutionized fields of data science you can use. You can use LSTM enabling, like you can do efficient processing analysis of sequential data. So sequential data is spirit of LSTMs, guys. Yeah, that you have to understand. As a research and developer continues, so we expect to see further advancement. Also, you guys, once you develop your foundation, you can also improve these models, guys. You can become researcher, design these new advanced level of, you can take the LSTMs to next level. So when you have right attitude, patience, persistency, consistency, and long-term vision, then and only you will have these things and absorb the information, digest, and apply. So there are vast applications and there will be a lot of opportunities, guys. It is just a start. Keep learning deeply. Let's move to the other section.
Yeah, guys, that's all about LSTM black box. Okay, we have learned end to end of LSTM in a theory concept. We're gonna see a magic. That is, in the next session, we're gonna see a coding part of LSTM where we're gonna see how this LSTM gonna work. We're gonna build a sample LSTM model and we're gonna train it and we're gonna see the inference. Okay. Hope you guys have enjoyed the session. If you guys have any doubt, just make sure you guys like put in the comment section. We'll take up and we will solve your doubts from that. And one more thing, guys, please subscribe to our channel, because like every day we are just posting a new video so that you guys gonna not gonna miss any of our videos, because while you subscribe you just press the notification icon. Okay, so that's the thing. And as sir is mentioned always, like we are having nearly 3000 plus quizzes that are live and available. Please go and attend the quizzes and make sure you guys have ready with a kind of MCQs kind of thing when it related to data science. Okay, so guys, yeah, this is all about today's session, guys. Hope you guys have enjoyed. We have enjoyed a lot and we have learned a lot. The next session we're gonna see the coding part of LSTM. So we will all meet in the next session. Until next session, bye guys. Take care. We will all meet in the next session. Bye guys.
Bye, guys. Take care and have the learning architect always with you. Write on a paper, and whenever you are attending the session, so keep the learning architect with you so that you always do reinforced learning, which is another architect for you guys. So go and watch all the sessions 5 to 10 times. That is, I'll tell you guys, all these models are built with a long term persistence, patience, and consistency. That is why they are doing magic. You also want to do magic? Go do iteration on learning. When you do that, reinforced learning will happen, magic will happen. I'm telling you. That is the magic thing. And you know how children learn, how when we are young, we do reinforced learning, that's it. And it is reinforced learning is actually inspired. The scientists they observe learning patterns from when child is born. It is all around you. It is just put into a complex models and structures. That's it. They are actually uh, we don't have teachers who understand these things and tell you. Okay, I have seen teachers, but we need great teachers who understand life first and then what is the architect of life. And once you understand it, learning becomes very simple. Reinforced learning is in children. Go and see, observe, and see. You will do magic when you apply that, okay, in your projects or wherever you are. So keep this attitude, positive attitude, and long term aspect, and this architect of learning. And let's see you in the other section and keep learning deeply, guys. Thanks.